Hello, Algebra 1 kids. We are venturing onto Chapter 9, and let's go here. Let's figure this out. Quadratics are a super important part of Algebra 1 curriculum. So we have the linear. Remember, linear makes lines. Quadratic makes parabolas, and which are U-shaped graphs. I'm looking at all my beautiful pens and deciding. Let us go with this color today on the first one. So one thing we talked about was how to look at something and determine with a list of values if it was quadratic. So second difference was the method we used. But first we had to look at the x values and make sure they were incrementally spaced. So we'd say, okay, we added 3 here, plus 3, and plus 3. So we're good there. Now we had to look at this bottom part here, and there's not a ton of room, so we could rewrite them, but go, okay, that's a minus 15. That's a plus 3. And that's a plus 21. So we know it's not linear. Remember, if it was linear, these would be the same right now, and we'd be done. That's the first difference. But for the second difference, we do the second difference on the y's, not the x's. They're good. So when I look at these from negative 15 to positive 3, remember we're thinking of it like a number line. And if we go from a negative 15 and we go past 0 to a positive 3, we actually are going 18, a positive 18. And then from 3 to 21, all the way up to 21, we are again going a positive 18. So that ends our search. So when we look, though, I do want to show you why these other ones don't work. If I do these, I go up to, up to, up to. That's linear. This one's down 8, up 56. So it's not linear, but if you check the second difference, that also will not work. This goes down 4, up 4. Second difference won't work. So the only one where it actually works is that. Question 2, identify the vertex of this parabola. So you guys, if you're ever given, this looks blurry or else my glasses are dirty, one or the other. The vertex, if you're given a graph, you can find things really easily by looking at a graph, can't you? So let's just talk about that. Identify the vertex, that's the tip point right here. So remember, a vertex, you always put your x first, then your y. So it's 3, negative 5. The next part of the question says give the minimum or maximum. So on the test, you're going to have to tell me, is it a minimum or a maximum? In this case, it's the lowest point of all these points. Remember, there's infinitely many points. This is the lowest one, so it's the minimum. And the value, you go to the y. It's over here. So this is my minimum value. It's the lowest point that it hits. The rest are all above it. All right, but when we are looking at this, remember there's other things you can see when you're given the graph. So I see a graph over here, so we're going to be able to find some things here too when we get there. But I can also see from looking at the graph that my axis of symmetry. I don't need to do the equation. I have it right there. I also can get my zeros or solutions, x-intercepts, solve. Those are all, that's all lingo for those 2 points there. Now this isn't a graph where they're really easy to see or anything, but it's something like, I don't know, about 3/4 of the way, and a little over 5, about 5 1/4. So if I asked you to locate or to solve or to find the zeros, I probably will put it right on the money so I know you know what part of the graph. But just realize that you can tell me the vertex, you can tell me the axis of symmetry, and you can tell me the zeros with somewhat, it may be slightly estimated, but it's pretty clear. All right. Use a table values. So the key part here is you're given the x's, you got to substitute them in and get your y's. And you just need to make sure you do the order of operations correctly, honestly. So I'm going to use this, and I'm going to rewrite this, and I recommend you do this on the test, and then use a pencil to substitute these different values in. But put the parentheses there where the x is supposed to go. So put in the -2. That way I can think, okay, powers first, not multiplying. So -2 to the power of 2 is 4 times 3, 12, minus 8, 4. Okay, then I can just go right back in there and put the next one. So -1 to the second is 1, times 3 is 3, minus 8 is -5. Okay, so we're just going to continue on doing this. It only takes a second to erase and put the next one in. 0 squared is 0, times 3 is 0, minus 8 is a -8. Okay, 0 is out and 1 is in. 1 to the second is 1, times 3 is 3, minus 8 is a -5. Then I'm going to put in the 2. We have 2 to the second power is 4, times 3 is 12, minus 8 is 4. Okay, so we can kind of see the pattern here. That's going to be the middle, isn't it? And then we have these on the side and these on the side. You can tell it's quadratic kind of from looking at that there. So 0, -8 falls right here. I don't know why I jumped in the middle there. -2, -4, -1, -5. Kind of wish, wait, whoa, what's wrong here? -2, one moment please. Sorry, I was hearing family members. So let me see here. So I have -2. Oh. There's the problem. You guys saw it before me, probably. These guys are on the ball. So I'm going to move that. Okay, what is wrong with this guy? Ah, there it goes. Yay. Okay, so I got something coming through here. Let's get that off. Okay, so -1, -2, 4 is up here. There we go. That looks better. -1, -5, 0, -8, 1, -5, and 2, 4. So kind of wishing I had a bigger graph on here for you guys. I should have spaced it out a little bit, but that's okay. We can still make it work. It's pretty narrow, but just do your best to make a U shape going through it, not a V. So that's kind of tough though, because I didn't give you the best graph to work on. So do your best. Next, find, zeros. That deserves a highlighter. Why? Because look at right there. So we talked about zeros over here. Remember, it was the location right on the x-intercept. So all we have to do, we don't have to get confused and see the formula and think factoring and all these other things. We can just look at the graph. Isn't that awesome? So x is equal to, if you solve this, -2 and, be very careful, 3. And if you put either of those in here, you're going to get 0, aren't you? That's why they call them zeros, because when you put it in, you will get a 0. Let's just try the positive one here. 3 to the second, just so you can see what I'm saying. 3 to the second is 9, minus 3 is 6, minus 6 is, ding, ding, 0. And the same will work with the -2. All right, 5, find the axis of symmetry on the graph. So this one you aren't given the graph, like up here, where you can find the axis of symmetry. So we will use our formula, x equals -b/2a. So first step I've always said is to go in here and put your a, 1, b, 10, c, 16. Write them, be clear, and substitute it in. The opposite of b. So I go over here and it's 10, so that'd be a negative 10. Over 2 times a, which would be a 2. X equals negative 5. My answer is C. If you graph, what would be the y-intercept? A equals 5, B equals 7, and C equals a negative 15. The y-intercept, I'm going to highlight that too because it's kind of fun, is always your C. So what is my C? Negative 15. Don't lose the negative with the subtraction here. Negative 15. That's where it hits the y-axis. All right. The height of a ball is in feet is modeled right here. So they give that to you where x, whatever value you substitute in, is the time in seconds after it's hit. How long will the ball be in the air? So basically, the bottom here is going to be the seconds. And this is the height of the ball. So we're saying if you put in 0 seconds, f of 0, is it hit? Okay, I'm just rereading it to make sure it wasn't one where they dropped it off. The ball is going to start here, right? And that does make sense. If you put a 0 in here for the height, that means if you put a 0 in, you're going to get 0. 0 equals 0. So 0, 0 is our first one. But now you can find the axis of symmetry, and once you find the axis of symmetry, actually that's the easiest because that's your halfway mark. Let me show you what I mean. You don't have to go through and graphing everything. I give you this to help you. But watch this. A, B, C. Exactly what you're familiar with. So A is what? Negative 16. B, 128. C, 0, which makes sense. Here's my y-intercept and it's 0. So I'm going to get the axis of symmetry. So x is equal to the opposite of b. Opposite of b is negative 128 over 2 times a. 2 times negative 16. That is a negative 32. So I'm going to get a positive 128 divided by 32, which is, I believe, 4, if my brain is calculating correctly. Let me see here. Okay, just double checking. So I have my axis of symmetry. It's right here. And then that's all you really need, because that is the reflection. You can reflect this point over, and you will know that that's where the ball hits the ground again. Because the question is, how long is the ball in the air? So in other words, you're going to hit it. It's going to go up. It's going to come down and hit. So it's saying, where does it hit? How many seconds? So all we did was we knew it started at 0, 0, because they're hitting it. It's starting off at nothing. And then we found out the axis of symmetry was here. So I knew that this point, 0, 0, will reflect over here. So 1, 2, 3, 4. 1, 2, 3, 4. My answer is right there, 8 seconds. There are a couple other ways you could do it, but that is the simplest. All right, comparing the graph. So there is the 3 basic ways, I would say. I just leave a lot of room here, but the first way is tell me about whether they go up or down. So we've got 2 graphs, and you should refer to them both. Unless they're both the same, you should clarify what is what, okay? So when I look at this, I say g of x, I see the negative. So I would say g of x opens what? Down, good. And then I would say f of x opens, it's positive, so up. So there's 1 point. You got to do 3 of them. We can look at the width. So what's the number right before the x? a 1, and a 1. Remember, when we're determining width, we don't take into consideration the negative because we already handled that here. We're just looking at the 1 and the 1, and since they're the same, that tells you that they have the same width. Remember, the bigger number actually is more narrow. And if this was a 4 and this was a 1, I would have said g of x is more narrow than f of x, or narrower. And lastly, we can look at axis of symmetry, because remember, when there's no x term, in other words, there's only an x squared term and there's a constant, there's no 5x or 4x or anything in either, that means that the axis of symmetry is going to be 0. So we can just say, since there's no x term in either, we have the same axis of symmetry, which is x equals 0. Or if they were different, you could get the axis of symmetry and just tell me what they were. So you're just telling me something about both. When you're referring here up and down, the width, the axis of symmetry, could tell me the vertex of both. Something about both. All right, so here we go. You should see the graph and go, oh, good. Because I might be able to just solve this by looking only at the graph. I don't have to get confused because I see all these variables and letters and start to panic. It says, use this graph. Oh, use the graph of the quadratic function. So they're telling you what it is, y equals negative x squared plus 2x, to solve the equation. That's a highlighter again. Why is that a highlighter? Because I think we highlighted it over here as well. Zeros, zeros, solve. So where do we look on the graph? It's about knowing what you can find on your graph. It's right here. Those coordinates on the x. So what are they? X equals 0 and x equals 2. Again, if you put in 0, you get 0. That works. If you put in 2, you're going to get 0. Done with that one. Then we get into all other ways of factoring. So solve this by factoring. So the first thing you're going to want to do is rewrite your equation down here very neatly. Got to keep this stuff neat. And we want to get this over to this side so that we have it equal to 0. So I'm going to add 4x on this side and add 4x on this side. That's gone. And when I rewrite these, I cannot combine them because that's a number and that's an x term. But I need to write them in descending order. So I put the x squared first. Then I'm going to write the plus 4x. Then I'm going to write the minus 12. And then there's nothing left over here, so I'm going to put equals 0. Now that looks like what should we try? Which solving technique? Box 1. So the two values we're putting in are 4 and negative 12. And we are trying to think of two numbers that when you multiply them, you get negative 12, and add and get 4. So let's start with the 12. 1 and 12. That's not going to ever give you 4. How about 2 and 6? That could give you 4 if you subtract them. So, and we do need a negative here, so one of them's got to be negative, but this has to be positive. So it's going to be a 6 and a negative 2. Double check, make sure I didn't make a mistake. 6 times negative 2, yes. 6 plus, yes, that works. So remember, this box 1 is the easier. You just pop them in. You don't have to work through everything. You just put your parentheses. And then you have x plus 6, x minus 2. And it does say by factoring, so you do need to work through this and show me your factoring right here. Now we are solving it. X equals, what makes this a 0? Negative 6. What makes this a 0? 2. And there's your answers that you will now look for. A negative 6 and a positive 2. Notice they're always going to do this where they're the opposite. That's why you have to walk through the process, solve, so you're very clear on what you're doing. All right. A stunt diver jumps from the top of a platform. So this is the situation where I was looking back when we were doing this one. I was like, oh, are we at here or here? Because for a minute I thought it was the problem we're about to do. Because if it's somebody jumping off a diving board, they're starting up here. They're not starting at 0, right? They're way up in the air. So that's what we got going on here. We got a stunt diver jumps from the top of a 96-foot platform, and the diver's height above water is modeled by this. Okay, so where h is the height in feet and t is the time in seconds. Find the time it takes the diver to reach the water. So the question is, when they reach the water, what will their height be? 0. They hit the water. They don't start at 0, they start up in the air. But when they hit the water, they're at height 0. So I can take this and put a 0, I'm just going to leave that blank right there, for h. And then we have to factor it and find out our answers. So the first thing I've always told you to look for is GCF. So you can use your calculator, and I can see there's a 16 and a 16, so we can make sure the 96, does that divide by 16? Yes. All right, so let's take out a GCF of not only 16, but a negative 16. So we're going to put that out in front of the whole thing. So I'm just going to rewrite now all three terms, dividing that negative 16 out. So then I'm left with the t to the second. And since this was a positive 16, it's going to change that sign to a minus t, and that's going to change that sign as well, and it was a 6, I believe. Now when you do that, it's a much more manageable thing to look inside here. What do you want to try? That's right, it's a box 1 situation. So I need, this one goes on top, that's a negative 1. This goes on the bottom, negative 6. And so we have to think of things. So let's start 1 and 6. Nope, add or subtract, I don't get 1. How about 2 and 3? Ding dong, right there. But I got to make sure I get the sign right. So I'll put them in there and then figure out the sign. I got to get a negative. So one of them has to be negative. Now which one would have to be negative to get a negative 1? Right, a negative 3. So, done with those. So I go over here now and pop that in. 0 equals negative 16 times t plus 2 and t minus 3. So again, now here comes our solutions. T is going to equal whatever makes this 0. And that is a negative 2. And whatever makes this 0. And that's a positive 3. Since t is time in seconds, I can't have a negative 2 seconds. So that one's not a viable option. My answer for this problem is 3 seconds. That's a tough one. That's probably the hardest one on the test. You might want to re-listen to that after this is all over, just to review that one more time. All right, next we have solve using square roots. So as you noticed, we had solve using the graph. We had solve by factoring. Now we have solve using square roots. So we have to follow what we're saying here. It's time to switch it up a little. So when I look at this, I'm going to do my work right here. I'm going to rewrite it. When I do this, what I notice is that I've got this square because I want to solve, but I have that square right there. So I have to do the opposite of that because everything in here is locked into that square. I don't have anything in front of it or below it to get rid of. The closest thing I can do is get rid of that. So I have to square root everything. This cancels with that. And I'm left with x minus 5 equals, and then the square root of 36, that's plus or minus 6. Now I'm going to add 5 to both sides. That cancels, and I'm left with this, which is interesting because I've got two options here. So I've got 6, the positive 6 plus 5, that's 11. Or I've got the negative 6 plus 5. and that is a -1. So my answers are 11 and a -1. And since it's not a real life problem, I don't need to cross any off. Both of those are options. And you can have a negative because when you put that in here and then you square it, it does become positive, which is what you get here. All right, now, which number completes the square to form a perfect square trinomial? So we're going to be working on the completing the square, but first thing we worked on was how to figure out this term right here. Okay, so that was one day's lesson where we talked about how to get that. And what we learned is that you can take b divided by 2 and square it, and you will make a perfect square trinomial. So remember, a here is 1, b is 7. One moment, please. Okay, and so we've got our b, so our b is 7. So we have 7 divided by 2 squared. So we don't want to use a calculator on this. We just want to square each of these individually. So 7 to the second power, 7 times 7 is 49. 2 to the second power, 2 times 2 is 4. And hopefully that's an option, and it is right here. So make sure you square the top and the bottom. Now we use that similar technique when we're completing the square, because the reason we did this was to see if we could form a perfect square trinomial, which would be that. Whoops. I can break it down like that. That's why we want to figure that out, because it becomes perfect. I use that in there and we have this perfect factor. So hopefully this one will work a little easier, but if not, we can work through it. Okay? So let's start down here. X squared plus 8x. And the first thing you want to do, actually, before I even go down there, is I'm going to minus that 18 and put it on the other side, so that I can have that blank space there. Then I've got the -18 plus blank space. So that's your first step. You only want the x squared and the x on one side. Get the other number on the other side. Now, we follow that technique we just did up here. So we have a is 1 and b is 8. So we want to do b over 2 squared. So the b is 8. Divided by 2 and square it. Yeah, this does come out nicer because 8 divided by 2 comes out even to a 4, and 4 to the second power is 16. So we're going to put that 16, and again we have to do it on both sides because we have an equal sign here. Can't do it to one that you don't do it to the other. Now, here's the cool part. This is a perfect square trinomial. It breaks down into something like that. So we can write it as x plus, and it's a plus because of this plus right here, and it's a 4 because of this 4 right here. It's the square root of whatever that was. Equals -18 plus 16 is a -2. All right, right there, you lucked out because we get to be done. Why? What happens when you square something? You get a positive number. What's on this side? A negative. How does a positive ever equal a negative? It doesn't. There's no real solutions. It's imaginary ones you'll work on when you get to Algebra 2. Now, just for practice sake, in case there's one on the test where it's not a -2, I'm just going to do this so you know what you would do if you had to keep going. So you would do the square root of both sides, and you would get x plus 4, because this and this would cancel, and you'd be left with plus or minus √2. Now I would subtract 4 on both sides to solve, and I'd have x equals, and I'm going to write this first, -4, and then I put both, plus or minus √2, and I'm done. And that's kind of where they put this in here, because if you didn't know to stop up here where you had that negative value and just be done, and you keep solving, you would end up with this actually, and you might have picked that as an answer. All right. We are almost done. We just have the quadratic formula, but I'm going to jump up to 16 before I do 15 because we actually did this first, where we figured out find the number of solutions. Remember, what are your options? 0, 1, or 2. So if any of you pick 3, you really weren't listening in class. Okay. So it's your only options are F, G, or H. Because when you have that problem, remember, your options are this, which is no solutions, this, where there's 1, or this, where there's 2. Right? Because the solutions are where your x-axis is. So let's take a look. So I have this, and you're going to put A equals 1, and B equals 10, and C equals 35. And we're going to use our B squared minus 4AC. That is what determines it. Let's solve that. B is 10. So I've got 10 squared minus 4 times A times C. All right. B, 10 to the second is 100, minus 4 times 1 is 4, times 35 is 140. 100 minus 140 is definitely a negative 40. That is a negative number. The number you get isn't as relevant, although I will be checking the work. So when you have a negative number, that means there are 0 solutions. And that is your answer, F. If you would have gotten a positive number, that's 2 solutions. And if you would have gotten 0 for an answer here, that would have been 1 solution. So that's a little tricky, isn't it? So you can make sure you review that before the test. Last one, then we're done. And it's a quadratic formula. Before you do quadratic formula, again, you have to get these all on the same side, which you do on almost everything except for completing the square. That's the one time where you're actually moving it over. The rest of them, you pretty much want them all on that side to take a look at it. So we're going to add 8 and add 8. So we have, I'm going to write it right here, 2x squared plus 7x plus 8 equals 0. Now we're going to use our x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. Uh-oh, battery saver is on. This will just kill me if I do not finish this. Okay. X equals, oh, I didn't put my a, b, and c. A is 2. B is 7. And c is 8. Now we plug them in. So the opposite of b. So I look over here and go opposite of b. That's a negative 7 plus or minus b squared. So 7 squared is 49 minus 4ac. So 4 times a times c. All over 2 times a. So x equals opposite of 7 plus or minus 49 minus. You have to do all these together. So I have 4 times 2 is 8. Times 8 is 64. All over 4. X equals negative 7 plus or minus the square root. 49 minus 64. We're getting a negative number in there, aren't we, folks? So again, square rooting a negative. Your actual answer here is no real solutions because you can't take the square root of that. If this was a positive 15, just for the sake of knowing, you would leave your answer like that because you couldn't break down square root of 15. And let's just say this was a 49 here. I'm just showing you the different options. Then you would say, oh, negative 7 plus or minus square root of 49 is 7 all over 4. And you'd calculate this. So negative 7 plus 7 is 0. Divided by 4 is 0. Then you would do negative 7 minus 7. That's a negative 14 over 4. That's a negative 7 over 2. And you can just leave it like that. Those would be your solutions. Okay, so it does depend on what is in there. I don't want to leave this with the wrong information for the problem. So I'm going to get rid of that. And that is a negative 15. All right, so that's it. Feel free to rewatch any that you had trouble with or need to hear again. All right, you guys are going to do great. Bye. Oh, wait, I didn't even show you anything exciting. Oh, I must have something exciting. I do have a new game. It's right here. I'm going to try it. It's a math game, of course. Did you guys ever hear of crypto? Wow, the lights are really bright there. Let's see. Crypto. Okay. So, I'm going to try that. I'll let you know. For all ages. All right. Bye, guys.